back, everyone, to another episode of Research Done Right. In today's lesson, Lesson 4, we're going to be talking about fundamental research issues. So if you recall, in the last episode, we had a very important discussion on the ethics of research in behavioral science. So now that you're in the clear and you know what you can do and what you cannot do when it comes to the APA Ethics Code, now let's dig in a little bit deeper to learn about variables, validity, and different types of experimental and non-experimental methods that you can use for your own research. So we'll begin our discussion by talking about variables. Now, if you've taken any type of research course, you should remember that the minimum number of variables you would need to conduct any type of research is 2. One would be the independent variable, and the second would be the dependent variable. We know that the independent variable is typically the cause, and the dependent variable is known to be the effect. However, besides causal relationships, we can also have correlational relationships between the variables. So after discussing causal relationships of independent variables and dependent variables, we'll also learn how correlations differ from those. And last but not least, but very, very important, we're going to talk about operational definitions of different variables. After we talk about variables, we'll start our discussion on validity. So when we think about something being valid, we think about the truth, the accuracy of those statements. And we have 3 specific types of validity: construct validity, internal validity, and external validity. By the end of today's lesson, you will be able to differentiate between all 3 types of validity. And to wrap up our lecture, we'll talk about different types of non-experimental versus experimental methods that you can use when conducting research on your own. So let's get started. When we talk about variables, we know that variables are defined as any event, situation, behavior, or characteristic that can change or vary. So even if you think about the word variable, the root word within that is to vary, and to vary means to change. So the values of our variables, they could be numeric or they can be not numeric, such as categorical or nominal. So in our next discussion on measurement, we'll learn about the 4 different scales of measurement we can use to identify our different variables. In the meantime, what you need to remember is that the values of the variables can be quantitative and qualitative. They can be in the form of a number or they can be in the form of a word. So the independent variable is the variable that is controlled by the researcher. Again, this is known as the cause when we're examining a relationship between 2 things. The dependent variable, on the other hand, is the variable that we are typically interested in measuring. In other words, the dependent variable is the result of what we do to the independent variable. In other words, the effect of the relationship. What's really important to remember when conducting your own research is that you want to maintain as much experimental control as possible. When we talk about experimental control, that means we are holding all extraneous variables constant. In other words, when you're looking for an effect in the dependent variable, right, you're looking for a change, that change should be due only to the differences that we are implementing, or the different severity or dosages or levels of the independent variable that we are manipulating. If you hold all other possible factors constant, then it means you are exercising experimental control. If you don't maintain those things constantly, for example, if you are interested in testing the relationship between the time of day and the energy a person has, you only want the differences to lie within the time of day. So you would have one group whose energy will be measured in the daytime, perhaps when it's sunny, and another group in the evening time when it is not sunny. You can also have a condition when it's rainy or foggy or snowy or sunny. So all of those are absolutely appropriate levels of the independent variable. And of course, the energy level is what we would be measuring, so it is the dependent variable. However, it's entirely possible that perhaps the food that people eat have a direct effect on the amount of energy they have, regardless of the time of day that their energy is being measured. So if you do not control the amount of food or the type of food that your sample has eaten, it's going to definitely have an effect on your dependent variable, and then your results will be convoluted. So when you have this other extraneous variable that could be having an effect on your dependent variable, we call that a confounding variable. And confounding variables are undesirable because, once again, instead of identifying differences in your dependent variable in your energy level depending on the weather or the time of day, what is actually causing the differences could be the nutrients that your participants are eating. Is it possible that the nutrients as well as the time of day could have an effect on energy level? Absolutely. But unless you experimentally control for that, unless you get information on the food that they are eating, that means that you're going to have a confounding variable. So in other words, a confounding variable is a third variable, right? It's called a third variable problem. It's any extraneous variable that can affect both the independent variable and the dependent variable. And it therefore eliminates this direct effect of the independent variable on the dependent variable and causes an indirect effect of the differences that you're seeing. The third variable problem also triggers the concept of what we know as alternative explanations. So if you remember back to lesson 1, when we talked about the 3 different elements that are important to determine causal relationships, the first one was temporal precedence, the order in which the events occur. The second one was covariation of cause and effect. Does the energy level change when we change the time of day? Or does the energy level stay the same? And then the third one was alternative explanations. So what else besides the time of day could actually be having an effect on the energy level, on the dependent variable? And so the uncontrolled third variable is called this confounding variable. And again, confounding variables are undesirable. There is a possibility in which you can control for this third variable, and in the event that you do that, it no longer becomes a third variable problem. It becomes what is called a covariate. So if you consider the time of day as the independent variable, the energy level as the dependent variable, and a possible indirect or direct effect of this third variable, which is the nutrition, the food the sample eats, in that case, you would have a covariate, and because you're actually knowingly acknowledging that there is this possible third variable, it is no longer a confound and it is considered a covariate. And there are specific statistical analyses like ANCOVAs, right? Analysis of covariance that can account for the variability that we see with the presence of a third variable. But again, if the researcher shuts his or her eyes to the fact that there is a possibility of a third variable, then it becomes a confound and it definitely affects the validity of your experiment. So sometimes it's really hard to keep a variable constant. So for example, if the researcher cannot actually cannot keep track of the types of food that the people eat, what we do is we try to make up for this with randomization. So when you collect a random sample, right, when you use random sampling as well as random assignments, the idea is that you will have a random enough sample that will represent an entire population, but it will also have just enough people who eat very, very healthily, who eat a lot of nutrients that would give them a lot of energy, but you would also have an equal number of people who don't eat that kind of food, who don't eat the nutrients, who would not benefit in terms of energy from the food they eat. So by using randomization, the hope is that you have an equal representation of both sides of this spectrum, right? Both degrees or all degrees of the severity of this third variable that could actually be causing an effect on the dependent variable. So again, randomization should always be used, but it's incredibly important to try to eliminate alternative explanations and the third variable problem as much as possible. So when we use randomization, it keeps the variables constant across the conditions. In other words, everyone experiences the same thing. We're not choosing only the people who eat healthy, and we're not only choosing the people who don't eat healthy. So that way we have a good representation, a good mix of people. So the healthy and unhealthy eaters will experience all the different times of day and have their energy level measured. So we're keeping it constant in terms of randomization. Now that we learned a little bit about the independent variable, dependent variable, and third variable, let's take a look at this paragraph and try to identify each type of variable given this example. Researchers conducted a study to examine the effect of music on exam scores. They predicted that scores would be higher when students listened to soft music compared to no music. 150 male and 50 female students were randomly assigned to either soft music or no music conditions. Students in the music condition listened to music using headphones during the exam. Students in the no music condition completed an exam as they normally would. As predicted, exam scores were significantly higher in the soft music condition compared to the no music condition. So the first question is, what is the independent variable? So here we see in the first sentence, it says, researchers conducted a study to examine the effects of music on exam scores. Typically, when you're looking at a statement like this, anything that follows the word effect of is probably a good indication that that's your independent variable. So our independent variable in this case is music. How many levels do we have of the independent variable? In other words, how many degrees of the music condition? Well, it looks like we have two, the soft music condition and no music condition. So in other words, you could say that the no music condition is like the control group. All right, what is the dependent variable? Again, going back to the very first sentence, the study was to examine the effect of music. So music is our independent variable on what? On exam scores. So exam scores is what we are measuring, at least the difference in the exam scores relative to the music is what we're interested in seeing the differences between. So the exam scores would be the dependent variable. What is the potential confounding variable? So if you think about it, there actually could be two. The first one, and hopefully you're thinking about this as well as I'm talking to you, but the first one would be the preference of music of these participants. What if you are someone who really enjoys listening to soft music and this is something that you already do and you're used to? And what if on the other hand, you are a person who constantly listens to music while you're, completing an exam? Well, probably not an exam, but you're probably a person who likes to listen to music when solving some type of critical thinking task or doing your homework, etc. And suddenly you're placed in the condition with no music whatsoever. So now what you're habituated to, what you're used to is now disturbed, and you're actually in a group that's the opposite from what you're used to. So it's possible that because you're doing something unfamiliar to you, that your scores would actually be lower. So the potential confounding variable is, what is the actual preference of these participants prior to the study, right? Do they actually listen to music already? Is this something new for them, or is this something that they're used to? The other potential confounding variable could be the use of headphones. I'm not sure how many of you ever tried to take an exam using headphones, but again, if that's something that could disturb your thought process or make you feel less productive in a certain situation, that is another potential confound. So far we have the independent variable is the type of music, soft music or no music. The dependent variable are the exam scores, and the potential confounds are the participants' preferences or preconceived feelings towards music in general, as well as, the discomfort of wearing headphones while you're taking an exam. So what is the hypothesis of this particular example? So in the last sentence, we see that as predicted, exam scores were significantly higher in the soft music condition compared to the no music condition. So again, the hypothesis, the guess, the prediction was that those students who took the exam while listening to music in the headphones would actually perform better than the students that didn't listen to music at all during the exam. Okay, so now let's talk a little bit about the different types of relationships between variables that we can have. So we know that we can have causal relationships between variables, but we can also have correlational relationships. So another word for these relationships are correlations. And we can have 3 or 4 different types. The first one is a positive linear relationship. In other words, as one variable increases, the other variable increases as well. Or as one variable decreases, the other decreases as well. So the idea about positive linear correlations or positive linear relationships is that both variables are moving in the same direction. For example, the more power Wonder Woman has, the more success she has in fighting evil. So because power increases, success also increases, and this is an example of a positive correlation. If the example was the less power Wonder Woman has, the less success she will have in fighting evil, would that be positive or negative? If you're thinking to yourself, that's also positive, you are absolutely correct. It's positive because both of the variables are moving down. As power decreases, my success to fight evil also decreases. So as long as the variables are moving in the same direction, either both going up or both going down, it is considered a positive relationship. On the other hand, if we talk about negative linear relationships, this is the inverse. So as one variable increases, the other variable would decrease and vice versa. So the variables are moving in opposite directions. In a positive correlation, both variables move in the same direction, but in a negative correlation or negative relationship, one goes up, one goes down, right? Or one goes down, one goes up, either way. But that would be a negative relationship. For example, the more villains Diana Prince fights, the less evil there will be in the world. So in this case, because the villains that are fought increases, but the evil decreases, this is an example of a negative correlation. As one goes up, the other goes down. So when you think about these relationships or correlations, don't read so much into the message of the statement. For example, it's obviously better to fight all of the villains and decrease evil in the world. That sounds like a positive thing to do. However, you can't really pay attention to the context of what the statements are saying when we talk about these relationships. So remember, if both variables move in the same direction, either both moving up or both moving down, regardless of the context, that is a positive correlation. If the variables move in opposition, in inverse relationship, then the correlation or the relationship is negative. The other type of relationship we could have is a curvilinear relationship. So curvilinear, kind of just like what it sounds, it starts as a curved line, right? So it starts to come up, then it kind of reaches a plateau, and then it starts to come back down. So kind of like a rainbow shape. So as one variable increases, the other variable increases as well, but only to a certain point before both start to decrease, right? So this inverted rainbow, kind of inverted U-shaped, kind of like a rainbow. The other type of relationship we could have, well, is actually no relationship whatsoever. So variables that are not related to each other at all. If you were to imagine this type of a graph, this type of a relationship, like a trend, it would be just a totally stagnant line. You wouldn't see any type of changes. And so the way we determine the strength of these relationships is using what is called a correlation coefficient. So again, there is a statistical analysis, typically the Pearson correlation, that is used to measure these types of relationships. And that analysis gives you a particular number. Now, this number typically ranges, this coefficient ranges from -1 to +1. And the reason behind that is that the maximum correlation between variables you could have is 100%. If we convert 100% into a decimal, you get 1.00, aka 1. So the sign, right, -1 or +1, tells us if the correlation is positive or negative. The sign tells us if both variables move in opposition or if both variables move in the same direction. So the polarity, the sign, negative or positive, has no effect on how strong the correlation is. What tells us the strength of the correlation is how close that number is to 1. So typically when you run a Pearson correlation analysis, you will get a correlation somewhere between 0 and 1. And again, depending if the relationship is positive or negative, it will have the corresponding sign. So let's take a look at some graphing examples of these types of relationships. If we look at graph A, we can see the x-axis is moving to the right and the y-axis is moving up. We can also notice that the dots, right, the data points in the graph start out small on both the y-axis and the x-axis, and they grow. So the farther to the right I move along my x-axis, the higher my data points get on the y-axis. So because both are moving up, that would be an example of a positive correlation. Now let's look at graph B. In graph B, I can see that at the 0 point on my x-axis, right, the horizontal line, I have data points really high on the y-axis. So it starts out very low on x, but very high on y. And what do you notice as we move to the right on the horizontal x-axis? We notice that as the x-axis is increasing, the data points get lower and lower on the y-axis. So if x-axis increases and y-axis decreases, that would be an indication of a negative correlation or negative relationship because the variables are moving in opposite directions. Now let's look at graph C. Well, if we were to try to draw a trend line, right, connecting the dots, as we call it, through these data points, it would be really hard to make any sort of cohesive line. And the reason here is because the variables actually are not correlated. It's kind of like a chaotic scatter plot of data, but there's no trend, there's no pattern that we're seeing here. So if you were to see something like this with your data, you would understand that your variables, in fact, are not correlated, and your correlation coefficient, which is represented by lowercase r here, would be very, very close to 0. So not +1, not -1, but 0, because 0 would indicate the fact that the variables are not correlated at all. And then let's look at graph D. Graph D is a great example of what a curvilinear relationship is. So for example, let's say that the x-axis, right, is the number of times you watch Wonder Woman 1984. And let's say the y-axis, right, the one going up, represents how much you liked the movie. Okay, so x-axis represents the number of times you watch it, and the y-axis represents how much you like it. So imagine you started out, it's like your first time watching it on the x-axis, and you kind of liked it. Then you started watching it a few more times, and you realize you start liking it more and more. Once you get to, let's say, the 5th time that you've watched it, then you start to get sick of it, right? Things start to bother you. You start to find all these like anachronisms and things that don't really make sense historically or geographically. And as you continue to watch it more and more, you start to like it less and less. So the curvilinear relationship is quite interesting. It starts off positive and then it becomes negative. But so why is our correlation coefficient closer to 0 than it is to 1 or -1? Well, if you think about it, right, whatever value you have that is positive, if you add a negative value to that positive value, they just cancel each other out. So if you had a +1 correlation and then suddenly became -1, then they would cancel each other out and you would be left with the correlation coefficient closer to 0. Okay, let's try to categorize and classify some of these examples and identify if they are positive, negative, or curvilinear relationships. First one, increased caloric intake is associated with increased body weight. So in this case, we want to see, are both of the variables moving in the same, opposite, or canceling each other out directions? It seems like calories are increasing and body weight is increasing, so that looks like a positive correlation. The second one says, as people gain experience in public speaking, their anxiety levels decrease. Okay, so gaining experience means more experience. Anxiety decreasing means it goes down. So experience goes up, anxiety goes down. that would mean it is a negative correlation or a negative relationship. The third one, performance of basketball players increases as crowd noise increases from low to moderate levels, then decreases as crowd noise becomes extremely high. So again, imagine x-axis is the noise of the crowd, the y-axis is the performance of the basketball players. So between low to medium, it seems like the performers are doing better, but then once it gets too loud, their performance starts to decrease. So that sounds like a curvilinear relationship to me. Then we have increased partying behavior is associated with decreased grades. Partying behavior goes up, grades go down, negative relationship. Amount of education is associated with higher income. So the amount of education, right, the more of it you have, the more education you have, the higher income is associated with it, right? So education increases, income increases, sounds like a positive relationship. Second to last one, liking for a song increases the more you hear it, but then after a while you like it less. So this is really similar to the movie example I just gave you. It's a curvilinear relationship, right? Because you start to like it the more and more you listen to it until you hit a certain point and you're like, God, I'm so sick of this song. And then you start to like it less and less the more you listen to it. All right, and the last one, a decrease in the number of headaches is associated with a decrease in the amount of sugar consumed per day. So headaches are decreasing and amount of sugar consumed is also decreasing. Is this positive or negative? So this is going to be a positive correlation because both of the variables are moving in the same direction. Nice job. Okay, now let's move ahead and talk about operational definitions. Operational definitions are incredibly important for your methodology section when you want to conduct your own research. Now remember, you have at minimum an independent variable and a dependent variable, or even if it's a correlation analysis, you have at minimum two things that you're looking to correlate, to compare. Can you have more than two variables? Absolutely. For example, if you want to see, going back to our experiment on the time of day and energy, level of energy, if you wanted to control for that third variable and add it as a second independent variable, which would be a wise choice, then you would have two independent variables and one dependent variable. However, it's very important that we define each variable according to the scientific method. In other words, we really need to make sure that we define our variables in the context of our given experiment. Let me give you an example. How would you define a word such as creativity? So sometimes people say, coming up with something new or novel or finding a new way to solve a problem, etc. But there are a variety of different ways that you can define creativity. Also, how would you define pain? Or if you're measuring pain, how would you go about measuring it? Would you ask someone, does it hurt or not? Would you give them a scale? How many anchors would you have in that scale? But basically, what is your exact definition of pain or creativity or even aggression in your particular experiment? So if you look up the definition of a word like aggression, or love, or justice, or happiness, or self-esteem, right? Any one of these concepts, any one of these measurements, right, you have to realize that as the researcher, in terms of methodology, you need to come up with a logical and reliable way to measure these variables. But if you are asking participants, how aggressive are you feeling today? For one person, aggression could mean that they punch someone in the face. For another person, aggression could be the use of sarcasm. For a third person, aggression could be experiencing road rage while driving. So because these words are so common to us and they can have different perceptions of meanings, it's really important for you as a researcher to define for your participants in the experiment the exact definition of the variables that you are measuring. When we do that, it is called an operational definition. Your operational definition is a set of procedures that you're going to use to measure and manipulate the variables in your experiment. This can include using specific scales, anchors, numbers of observations. For example, if you were observing behavior of children in a childcare and you were interested in measuring the level of aggression of these kids, again, remember they're kids, so they're probably not really going to understand your definition of aggression if you ask them how aggressive they're feeling. So you choose to observe them in their natural environment. So let's imagine that you are observing these kids on the playground. How would you define aggression in terms of what you are looking for in your observations? And additionally, as we'll learn in a moment, you shouldn't be the only person doing these observations, right? You should have another rater rating these behaviors and these observations, as we will learn, is called inter-rater reliability. So both of the researchers need to agree on what is considered aggressive and what is not considered aggressive when making these observations. If a child pushes another child, would that be considered an aggressive behavior? Or if a child uses a bad word to talk to another child, is that an example of aggressive behavior? So again, you as the researcher have to set very, very specific limits and criteria that will define your variables. Otherwise, again, your validity will be affected. So speaking of validity, that is our next topic. So when we think of the word valid or validity, we typically think about something being true and correct. When we talk about validity in an experiment, it's basically our decision, right, to determine whether the information that is given to us is true or not. Specifically in terms of research, we have what is called construct validity. And construct validity refers to the adequacy of the operational definition of the variables. In other words, does your operational definition actually reflect the true theoretical meaning of the variable? So let's go back to our aggression example. Outside of the context of your research experiment, when you think about aggression, typically it's like a negative emotion. It often leads possibly to like violence, some type of rude behavior, something that's possibly socially unacceptable, not a nice way to behave, etc., so on and so forth. So when you are creating your operational definition, you probably want your definition to be in line with what is typically known as aggression or aggressive behavior. You want them to match, right? You want them to be related. Otherwise, you are definitely hindering the construct validity of your particular experiment. The other type of validity we have is internal validity. Internal validity is the ability to draw conclusions about causal relationships from the result of our study. So you can think of internal validity as very similar to those three facets of causation: temporal precedence, covariation of cause and effect, and alternative explanations, right? So internal validity says that we have strong causal inferences and we can make them based on those three things. And last but not least, we have external validity. External validity is the extent to which the results of our study can be generalized to other populations or settings. In other words, can our results from our study be replicated in other settings, with other participants, and with other operational definitions? So the catch here is that sometimes internal validity and external validity oppose each other. Let's think about this for a minute. Previously, I told you that it's very important to control all of your variables, right? We want to have experimental control. We want to make sure that everyone experiences the independent variable in the same way. So a common way that we do that is by using laboratories for testing. That is one way that we can collect research. So if we bring participants into a laboratory and we artificially create, the time of day, Or perhaps we constantly are testing only a specific ethnic group or people who live in a particular region and belong to a specific socioeconomic status. So we're controlling for all of these things because we want to make sure that the results that we are finding are in fact causal. The differences that we are seeing in the dependent variable are specifically due to exactly the changes we're making in the independent variable and no other extraneous variables. That makes our internal validity really high and really strong. On the flip side, if you're talking about generalization, and let's say you want to publish and say, this type of research, these findings apply to people everywhere, no matter their age, their ethnicity, their socioeconomic status, it would be really hard for us to make that generalization because we didn't test all the people in all the socioeconomic statuses at all different times of day, in their natural habitat, so on and so forth, right? We had so much experimental control that we are only able to generalize to the sample and to the criteria that we actually tested in our laboratory. And so that's why we say that sometimes internal validity and external validity oppose each other. If you have strong internal validity, that means you have great experimental control, you eliminated confounding variables. But it means it's going to be really hard for you to generalize it to people across all geographic locations and all types of participants. On the other hand, let's say your internal validity is lower because you didn't have that much experimental control. For example, if you're doing observational studies, going back to our child care observation of aggressive behavior, you didn't have control over how many students were playing together. You didn't have control over the time of day. You didn't have control over what the students did prior, to playing in the playground that may have had some type of effect on their aggressive behavior. But what you would have is more external validity because you would be able to generalize to kids who play in a playground in their natural environment, not being confined to a laboratory setting. So what's the solution here, right? Do we want more internal or external validity? Well, you definitely want a little bit of both. But again, you want to make sure that you are paying attention and you are aware of how your choices and your decisions for how you conduct your experiment will affect construct validity, internal validity, and external validity. So the last thing we're going to talk about is experimental versus non-experimental research. So we briefly touched on this as we were talking through our lecture. And so if we think about it, experimental methods are when we use a direct manipulation of variables and we strive for experimental control. So again, experimental methods are when you as the researcher have the power to manipulate the independent variable, whether this is changing the time of day, changing the type of food, increasing or decreasing a particular temperature, giving them more dosage of a medication or less dosage of a medication. In other words, you as the experimenter have control over the independent variable, over how much of it you are going to be administering. And then ultimately, if you have a lot of experimental control and high internal validity, then you will see accurate differences in your dependent variable that are not due to chance or coincidence or some alternative extraneous variable, but the differences are in fact due to the changes that you are making to the independent variable. So experimental methods are testing the direct effects of the IV on the DV, of the independent variable on the dependent variable. Now, given certain situations like when there's a pandemic and you can't actually talk to people or give people things in person and measure the differences that they feel or exhibit, we turn to non-experimental or what are called quasi-experimental methods. And these methods involve studying relationships, often by making observations or using some type of a survey when participants will self-report information to you. So an example of a non-experimental or quasi-experimental method would be an interview. In an interview, you're just looking to find more foundational or exploratory information on a particular topic. You're not actually there to test the effect of some independent variable on a dependent variable. You're there just to talk and find out information, perhaps about a particular experience they had, or case studies are also examples of these types of studies that would involve an interviewing method. The second one is a direct observation, or as we call field research. So going back to our observations of children in the playground for aggressive behavior, that is non-experimental, quasi-experimental, because you're making observations directly in their natural setting. You're not actually manipulating anything. You don't have experimental control. So again, your internal validity would be low, meaning it would be very hard for you to make any sort of conclusion on a causal basis. The third one would be examining public records. So for example, whenever you want to look up statistics about something, or perhaps the city you live in, like in criminology, right? In criminal justice, they like to look at police reports over the course of, let's say, 10 years. So doing something like that, when you would examine such records, that is called archival research. So you're not actually manipulating an independent variable and testing the difference on the dependent variable. What you're actually looking at is changes over time, given any type of variable that you're interested in. So you're not actually manipulating anything. You're not administering anything to participants. You're just looking at archival information, at previous records. And so these non-experimental or quasi-experimental methods are typically analyzed using a correlation, and for that reason, they are often described as a correlational method. Okay, so just to recap, in this lesson, we learned about the importance of operationally defining your variables, and we know that at minimum, we have an independent variable and a dependent variable. The independent variable is our cause, the dependent variable is our effect. We have to be careful of confounding variables or the third variable problem. And the way we mitigate that is by experimental control and randomization. After that, we discussed validity, and we have three main types. Construct validity. So does your operational definition actually match what society understands your variable to be? The second one is internal validity. How strong or accurate is the relationship between your independent variable and your dependent variable? In other words, is your dependent variable truly being caused and affected by your independent variable? And then the third type of validity we talked about is external validity, and that is the degree to which you can generalize your results to the larger population. And remember, internal validity and external validity share an inverse relationship. And the last thing we talked about were experimental versus non-experimental methods. And again, you have all of this knowledge. You have the choices to use a variety of different methods. Which method is the best to use? Well, it really depends on your type of research question. But the good news is you don't only have to choose one. Many researchers use a combination of methods to get stronger internal and external validity. So you don't always have to pick just one. Remember, there is a possibility to use mixed methods. As always, thank you so much for watching, and I will see you next time on Research Done Right.